Hello, and thank you for tuning in to this video demonstration about how we can incorporate transportation costs into our inventory-related decision making. Specifically, here we are looking at a scenario where we have two companies, Wagner, which is a manufacturer of electronics and components, as well as a distributor, which we will simply call electronics distributors. Now, these two companies do business with each other, and we're currently looking at a situation where we have to choose a transportation mode. Specifically, Wagner could either use rail and intermodal transportation system or trucks to ship all these electronics components to an electronic distributor. Now, what I want to show you here is how this decision will be impacted not only by transportation costs consideration, but also by inventory holding cost consideration at both Wagner's and electronic distributors. Now, one important thing I should mention before I get going here is that we will assume FOB destination. That means free onboard destination. What that means is that Wagner pays for transportation costs, and electronic distributor pays its supplier a unit cost that is inclusive of transportation costs. So that will be relevant as we look at some inventory holding costs on the supplier side. So let's simply go through the worksheet here. We're going to take a look at Wagner first. This is the upper portion of the table. And then we're going to look at the relevant costs for electronics distributors. And then we'll look at total supply chain costs. So let's take a look at Wagner first. Clearly, it is relatively easy to figure out what total transportation costs will be for the different modes. We simply have to realize that these transportation costs are simply the annual shipping volume, which is the annual demand volume, or lambda, multiplied by the corresponding rates. So for rail, the rate is $25 per unit. Now likewise, it will be the same, of course, for intermodal, total shipping volume times the intermodal rate of $33 per unit. It's a little more expensive because we use more expensive transportation modes along the way. And then finally, truck will have the annual volume multiplied by the truck rate of $45 per unit. So this is relatively straightforward. So now let's take a look at in-transit inventory holding costs. We have to realize that these transportation modes not only differ in terms of their rates, they also differ in terms of how long it takes. Of course, the longer the transit time, the higher the in-transit inventory holding cost. If we look at rail, for example, in-transit times are 16 days as opposed to 10 days for intermodal and 4 days for truck. So our in-transit holding costs will be a function of the time every unit spends in transit. First of all, how many units will spend some time in transit? Again, of course, the total annual demand volume of lambda. Now let's take a look at rail first. How long will these units spend time in transit? Well, we know that it is 16 days. However, now we've got to be careful because the inventory carrying charges of 25% are actually given in annual percentages. So this is 25% per year and not per transit time. So we want to divide those 16 days by 365 days to get the proportion of the year during which the items will be in transit. And now we simply have to multiply this with the per unit holding costs. And this is simply the unit cost C. And now we subtract from that the transportation rate multiplied with the inventory carrying charge. Now why do we do that? Well, we have to subtract the transportation rate from the unit cost because remember we are talking about Wagner here, the supplier, and the unit value for them is essentially the unit cost minus the transportation costs. Because at this time the unit is in transit inventory, it does not have the value added of that transportation cost just yet. So we can, for example, assume that transportation services are paid upon delivery. So the actual value of the good, while it is in transit, is net of transportation rates. So this is why we subtract transportation rates from the unit cost before we multiply this cost figure with the inventory carrying charge per year. So in this case, this gives us an in-transit inventory holding cost of $260,274 for the rail mode. And now we'll simply do the same things for the other modes as well. So for intermodal, again, we'll have all units at some point in transit inventory. We'll multiply that with the lead time, which in this case is 10 days divided by 365. Again, because we have to take into account that the inventory holding factor is per year and not per transit time. And then again, we multiply that with the unit cost net of transportation charges and multiply all that by the inventory holding cost factor per year. And finally, we'll do the same thing for truck again. The annual demand multiplied by the transit time of only 4 days, in this case, divided by 365, times the unit cost net of transportation charges multiplied with the inventory carrying charge of 25%. So this gives us in-transit inventory holding costs. Now let's take a look at Wagner's cycle stocks. Well, of course, Wagner's cycle stocks will be a function of the order quantity. So as usual, we assume that average inventories are simply equal to the average order, or in this case, shipping quantity. And when we talk about rail, we talk about a shipping quantity of 10,000 units. So in this simple scenario, we'll assume that Wagner has a cycle stock of 5,000 units, or Q divided by 2. And now we will multiply that again with the unit value, and that again is the unit cost net of transportation costs. And we'll simply multiply that with the inventory carrying charge per year. Now we do the same with intermodal. Again, we'll take the corresponding Q, divide it by 2, and multiply it with the unit cost net of transportation cost times I. And now finally we'll do the same thing for truck. So we'll have a Q of only 5,000 divided by 2 to get the average inventory level, multiply it with the inventory carrying costs per unit per year, which is simply C minus the transportation rate times the inventory carrying charge. So we're looking now at Wagner's total logistics costs as a sum of these three cost components. So it's rail plus inventory holding in transit plus the cycle stock holding cost for a total of $2,104,000. As you can see, it will clearly be more for intermodal and truck. In other words, the cost advantage of rail makes it very attractive to Wagner to use rail than any other mode, even though in-transit and cycle stock inventory holding costs will be higher. And this, of course, is relevant because it's Wagner that pays the transportation costs because we are shipping FOB destination. So clearly, if Wagner were to choose, they would go for, not surprisingly, the cheapest transportation option, since they have to pay for it, which of course would be rail. Now let's take a look at it from the perspective of electronics distributors. Again, an electronics distributor pays transportation costs as an inclusive component of the unit cost. They don't have in-transit inventory holding costs because in-transit inventory is owned by Wagner and not by electronics distributors. And so the only cost we need to consider for electronic distributors is the cycle stock holding cost. We will assume there is no ordering costs. So the cycle stock holding cost, of course, now simply is average inventory times unit value times inventory carrying charge, or in other words, it is simply Q divided by 2. So for the rail, it will be 10,000 divided by 2 times the unit cost for electronics consumers, which is $500 times the inventory carrying charge per year. We'll assume that this is the same inventory carrying charge as for Wagner for 25%. So we're going to have $25,000 carrying charges for electronic consumer alone. And then likewise for intermodal, we'll have an average inventory of 3,500 units for total inventory carrying charges per year of $437,500. And then finally, of course, truck. Again, even lower average inventories, and we see that the inventory carrying costs per year would amount to 312,500 units. And of course, you see clearly electronics consumer would much rather use truck as a transportation mode. Why? Because they don't have to pay for that extra cost of truck relative to rail, but they would benefit from the shorter lead times, and also more importantly, in this case, they would benefit from lower order quantities and consequently lower average inventory levels. So here you see the dilemma. Wagner wants to use rail, Electronics Distributors wants to use truck. Well, what if we take a global optimization perspective? What if we want to try to minimize total supply chain costs? Well, let's take a look at the sums of those two costs and you will quickly see what happens here. If we sum up the costs of Wagner and Electronic Distributors, you'll see that the lowest cost option would actually be to choose the intermodal transportation. That way we would minimize the sum of the cost to Wagner and Electronic Distributors, who would maximize the supply chain efficiency. I hope this illustration here helps you. As always, if you have questions, feel free to ask me anytime, and thank you for watching.